Here's a solution to number 20 on the PSAT review. This is a classic problem. There's a hard way and an easy way. The harder way is you look at this shape, and what I've done is I've drawn some dotted lines in here. You've got a square and then these semicircular segments, and I've drawn these dotted lines in the middle because, for example, if you draw these two dotted lines here, this part of the shaded region is exactly a semicircle. Or sorry, it's a quarter circle, okay? It's a quarter circle of known radius. That's a quarter times pi times 3 squared, okay? And similarly, this guy is a quarter times pi times 3 squared, okay? So the overall idea here is we're cutting something up into familiar looking pieces. Well, we've found two familiar looking pieces. Ooh, what about these guys? Okay, well, let's just look at this little 3 by 3 square. The shaded part is everything but what's inside a circle. Oh, okay. So this would be, this here that's not shaded is a quarter of pi times 3 squared. And this is another quarter of pi times 3 squared. So you could add it up as, we know these guys are shaded, and then you could take the 3 squared here, so the shaded bit is going to be 3 squared, or 9, that's the whole little quarter square, minus 9 pi over 4. And now this guy, of course, was 9 pi over 4. This guy is 9 pi over 4. And this guy is the same as this guy, so using symmetry, basically. 9 minus 9 pi over 4. And you could add these up. That is not a horrible way to do this, but notice what happens. When you add these guys together, the 9 pi over 4's cancel. And when you add these guys together, the 9 pi over 4's cancel. Okay. And, ooh, sorry, that isn't all over 4. And so what are you left with? Just a 9 plus a 9 is 18. There must be a simpler way to do that. It's such a simple answer, and it doesn't even involve pi. Okay. Well, the answer, the simpler way to do it, is to look for, again, look at the cut and paste method, but look deeper at cut and paste. You can cut and paste regions to figure out their area, and you can move the pieces around. It's called dissection. And this actually is a classic example. It's called a hinged dissection. If you separate it out into these 4 pieces, cut it along these 2 dotted lines, which are very natural because they separate it out into individual pieces that have to do with just the individual 4 quarter circles, and take this piece here and put a hinge on it and wheel it around. It wheels around to exactly fill in this part. This is a quarter of the big square minus a quarter circle. That's exactly what this part is. Now wheel this big piece here, take this big piece here, put a hinge here and wheel that around, boom. That exactly fits in here because this is a quarter circle, this is everything but a quarter circle, so they match together. Totally, it's exactly just the area of this rectangle, which is 3 by 6, and 3 times 6 is 18. Okay. I circled a lot of stuff there. It's a very, very messy diagram now. But this idea of cut and paste, and then you can move the pieces, and you can always reshuffle the pieces. This would be much, much easier if they actually gave you this piece and gave you, like a piece of paper, and gave you scissors or something and say, okay, cut it up and then play with it and see what's the simplest figure you can rearrange. But you can visualize that as well.